Welcome to Week 6, Planning Projects. Please read Chapter 12 in the Verzu textbook, along with selected readings from the PMBOK. Reread Chapter 10, pages 195 through 201 on estimating work packages. In the Canvas Learning Management System, we are on Module 6, where you'll find the usual overview, agenda, assignment, and lectures for this week. For your course project, you'll be completing a budget. Last week, our focus was on scheduling. We continue the planning process this week and focus on estimating the project budget based off of the WBS and the schedule. This week, we're going to talk about three primary areas in project estimating. Estimating fundamentals, which is a variety of different tips and tricks for estimating. Estimating techniques, which are specific estimating techniques that you can use to calculate your budget. And then finally, building a detailed budget. On this first slide of estimating fundamentals, we want to talk about how all projects are unique. Projects involve different people, different teams. There's always a unique dynamic to every project. There's new technologies. Even if you're iterating the same software or the same product, you're going to be including new technology, new features that will make it unique. And then lastly, the timing or the schedule. Different times of year will allow you to get different resources or different conditions that may impact your estimates. Continuing on estimating fundamentals, we want to talk about classic estimating mistakes. Ballparks, swags, elevator estimates are all the same. They're quick, off-the-cuff estimates that you're forced to give by a superior. You want to avoid doing that at all costs. Find a way to delay in giving an estimate. Tell them you need more time to get a more detailed estimate. Again, avoid giving ballparks, swags, or elevator estimates at all costs. Estimating without complete specification or requirements. You have to get some level of understanding of what you're estimating before you give an estimate. Confusing estimates with a bid. Bids usually involve the estimating process, but also put a profit margin on top of the estimate. And then finally, the last mistake is padding the estimates. In my philosophy, I feel that people are really good at estimating. We do it 1,000 times a day. When you drive up to a stoplight, you have to calculate if the light is yellow, you have to calculate whether you're going to hit the gas or if you're going to hit the brake. When you wake up in the morning, you calculate or estimate how many times you can hit the snooze button and still make it to work on time. So we are really good at estimating, but we've been tainted all these years by giving good estimates and then people expecting us to live up to those high accuracy estimates. Continuing with classic estimating mistakes, having the right people make the estimates. You want to make sure that the people that have the experience or the people that are going to do the work are the people giving the estimates. The last thing you want to do is have people that know nothing about the project, won't be involved in the project, come up with the estimates. Base the estimates on experience. Once again, you have a wealth of data that you might be able to use from past projects, similar projects, or from experts that might be available to you to help you calculate estimates. Never negotiate the estimate. It is what it is. You can negotiate the equilibrium of the triple constraints, and we'll talk more about that next week when we talk about trade-offs. Now let's move on and talk about some of the estimating techniques that are available to you. The first one Verzu defines is phased estimating, also known as rolling wave planning. Here, at the end of each phase, you'll have the opportunity to reassess where you are, where you need to be in terms of an estimate. The next technique is called apportioning. This is a top-down approach where, based off of experts, you come up with an estimate. Then you break down that estimate by phase or deliverable, similar to what you did with the WBS process. Next, we have parametric estimating, which is really a math problem. Cost per square foot, cost per line of code, cost per mile. The last one listed here is bottom-up estimating. This one takes the most effort, but it is also the most accurate. You need to have the lowest level of your WBS at the work packages or activity level to do a bottom-up estimate. Now you're ready to build a detailed, accurate budget. This will require two tools and techniques. The first one being a spreadsheet, and the second one being simple addition. You'll put all your information in a spreadsheet, and essentially you'll just add up the various costs, including labor, equipment, and supplies. Lastly, I want to introduce you to the cone of uncertainty. This is a tool that has been out in the project management ether for many years. And as you can see in the diagram here, early in a project, during project definition, we give what is known as an order of magnitude, plus 75% or minus 25% degree of accuracy. Later in the project, we can do a detailed technical requirements. We can give a budget estimate, plus 25% or minus 10%. And then finally, once we have detailed development designs, we can give a definitive estimate, plus 10% or minus 5%. And eventually, at the end of the project, we will be 100% accurate. In closing, please remember to participate in the discussion boards at least 4 times, responding to me and your peers, including that key takeaway item. Read responses and keep the conversation going all week. Watch for announcements, complete your quiz and your course project deliverables by the end of the week. Contact me anytime via email or text. Thank you and have a great week.